Hey guys, Miss Davis here. This is Unit 5, Skill 1A. Notes, Focus, and Directrix, Part A, Y equals equations. So pause the video to write down your essential question. How can we write the equation of a parabola given the focus and directrix? Okay, so looking at the visual here, this is an example of what we're talking about, the focus and directrix. These are some brand new vocabulary words that you've never heard before. So this right here, there's your parabola, so that U-shaped graph that either goes up or would face down. And we're going to go through some vocabulary just to introduce it. So first and foremost, the line that cuts the parabola down the center is called the axis of symmetry. So over here it says axis of symmetry, the line that divides the parabola into two halves, making it symmetric. And then there's the axis of symmetry formula if you ever need it. So x equals negative b over 2a if your equation of the quadratic was in standard form. So the first vocab word is the focus. So the focus is this word right here. So focus is a point on the inside of the parabola on the axis of symmetry. So the focus of this parabola is this dot right there. It's the point, again, on the inside of the parabola that's right on the axis of symmetry. The next word is the directrix. So the directrix is a line outside of the parabola perpendicular to the axis of symmetry. So this line right here is the directrix. Okay, so they'll always give you this equation, and it's always going to be, for these ones, y equals a number. Okay, and then your focus is always going to be a coordinate point, x comma y. Okay, and then the last piece down here is the distance from the, the distance from the focus to the vertex and the distance from the directrix to the vertex are the same, meaning this distance right here from the focus to the vertex is the same distance as the distance from the vertex to the directrix. Okay, and you always write your parabola or your vertex as h comma k. Those don't need to be pink. As h comma k. Right here, and we'll use that again in a couple minutes. And the distance between the focus and the vertex are always going to be noted as p. And again, they're always going to be equal, the same distance. Okay? So just some introductory language, some introductory visuals, and go ahead, flip over to the next page. Okay, so for example number 2 here, it says sketch a graph of a parabola. So you're going to sketch the graph of the U-shaped graph with a focus at the point 0, 7 and a directrix of y equals 3. Okay, now in order to sketch a graph, I have written up here, in order to sketch the graph of the parabola, you must have 1, the focus, 2, the directrix, 3, the vertex, and p, the distance between, 4, the distance between each of those, the vertex and each of the other two. Okay, so now we're going to sketch the graph. So the focus is at the point over 0, up 7. So let's say 7 is here on the y-axis. We're going to put a dot right there, and that's our focus. Okay, then the next piece is the directrix of y equals 3 is going to be, let's say down here. Here's 3 on the y-axis, so our directrix line is going to be right there. Okay, so that's y equals 3. Now the next thing we need to do is find the vertex. So the vertex is going to be halfway between your focus and your directrix. So if we take a look, the whole distance between each of those, so between your focus and your directrix here is 4 units. So between 3 and 7, if you subtract them, you get 4. So then we need to figure out, well, half of that is 2. So if I put a dot here, then what's halfway between 3 and 7? Well, this one's relatively easy. The halfway between those two numbers is 5. So our vertex is going to be at, so I'm going to write vertex is at the point over 0, up 5. Okay, so now what we need to do is actually sketch the vertex. Sketch the parabola. So if my vertex is here, then it's either going to go up this way or it's going to go down that way. But over here I have written that it has to open upwards for this one because it cannot ever cross over the directrix. So what I mean by that is you can never have something that looks like this. If you sketch it and then you've got your vertex and your directrix here, you can never have it go and cross over the directrix. So this is a no, no. So you can't do that. It's always got to open away from the directrix. So when I draw my vertex or my parabola here, I'm going to start it here and go up that way and that way. Okay? So one more thing we have to note is our p-value. So up here we said that we need p, and p is the distance between the focus in the vertex and the directrix in the vertex. So if we look at that distance in between there, this distance from here to here is going to be the same as from here to here. And in both of those cases, we get that the distance is going to be 2. So it's 2, oopsies, that's my highlighter. So the distance in both cases is going to be 2 and 2. So that means that our p-value is 2. Okay? So I'm going to write kind of up here that our p is positive 2. Our vertex is equal to over 0 up 5. Okay? So we have everything that we need in order to write the equation of this graph. And what the next part of the notes is actually how do we now write the equation of a parabola given the focus and directrix. Okay? So it says here we are used to seeing equations for parabolas in this general format where it's ax squared plus bx plus c, but we need to learn how to write the equation of a parabola given the focus and directrix. This formula right here is something that you need to memorize, unfortunately, but hopefully once you use it a few times it won't be too bad. So you need to memorize that formula right there. So the formula is 4 times p, so the p-value, parentheses y minus k equals x minus h squared. So hk represents the vertex, okay? And p is the distance between the focus and the directrix, just like we talked about. And, I'm sorry, between the focus and the vertex, and between the vertex and the directrix. So if a parabola is open up, p is positive, and if it's open down, p is negative. So if it's up, then p is positive, and if it opens downward like that, then p has to be negative. Okay, so these steps right here are just what you could follow if you need a little thing to follow. So plot the focus, draw the line for the vertex and the y equals horizontal line, find the middle, and so forth. So you could go ahead and follow these steps whenever you go to write the equation. So step 2, find the middle between f and the directrix. This gives you the vertex, just like we did up above. Half the distance between those two and find the p-value. Draw the parabola opening away from the directrix. Write the equation, plugging in the p-value and hk, the vertex. Get it into y equals, leaving the parentheses, so don't distribute. And then step 7 is check it in the calculator. You would hit graph, menu, 3, 2, 2, parabola. Okay, so now we're going to use this information to write the equation of the parabola that we sketched up above. So I'm going to copy down the formula and get you in the habit of using it to start. So I'm going to copy down the formula as 4p parentheses y minus k equals parentheses h or x minus h squared. Okay, so when I go to plug this stuff in, we have our p-value here, and our vertex is h comma k. Okay, so I'm going to plug in 4 times the p-value of 2 parentheses y minus, now my k value is 5, close parentheses, equals x, and then minus h, so my h in this case is 0, so minus 0 squared. So x and y will always remain the variables in these equations. So I'm going to go ahead and multiply the numbers on the outside, so I get 8 parentheses y minus 5 equals parentheses x minus 0 just turns into x squared. Okay, so now our goal is to get y by itself. So what I'm going to do is I'm going to divide both sides by 8. So divide this side by 8. Those cancel out. I can drop the parentheses and just write y minus 5 equals, now I'm going to see there's a 1 out in front of the x squared. I'm going to rewrite this as 1 over 8 x squared. Okay, and then our last step is plus 5 plus 5. And final answer leaving us with y equals 1 over 8 x squared plus 5. Okay, so that would be how you get it into final standard form, just like we had down here. So your x squared is first. Our b term actually canceled out for that one because it was a 0 there, and then plus our constant term 5. Let's go on to the next page and try another one. Okay, so it says sketch the situation, then write the equation of the parabola. So I'm going to go ahead and sketch by drawing my x and y axes. So I've got my y axis here and my x-axis going this way. Okay, and then I've got the focus right here at negative 4 down 13. So I'm going to go left 4 and then down 13, so down to negative 13, and put a point where that would be on the graph. So that's our focus. And then our directrix is going to be right here, y equals negative 5. So I'm going to go down to negative 5, which is right about there. I'm going to estimate where it is and draw a dotted line to show the directrix. That's y equals negative 5. Okay, so now our goal after this is to sketch our parabola. So in order to sketch the parabola, so we know it's either going to go this way, because it's got to be, the vertex is going to be somewhere between, or directly in the middle of our directrix line and our focus point. So it's going to be somewhere right in here. We just have to find the exact coordinates, and it's definitely going to open downward because we cannot have it open up towards the directrix again. So I'm going to go ahead and draw in the parabola. So it's going to be, the vertex is right here, right in between, and it's got to open downward. Okay, so now our goal off to the side, we know we have to find the, we need to find the vertex, and we have to find the p-value in order to write the equation of it. Okay, so what we need to do is we need to look and see how many units are between our directrix line and our focus, and then cut that in half. So what you could do is you could take the negative 13 minus negative 5, subtract the two numbers, so that turns into plus, and we get negative 8. And then, so we know it's negative 8 units between those two, and then our second step is to cut that in half. So divide it by 2, and we would get that there's negative 4. So between here and here, here and here is 4 and 4, but because it's opening downward, we need to have our p-value being negative 4. Okay, and then we need to figure out what the vertex is by looking at what that actual point would be. So we know that our point would have to have, so our vertex over here, we're definitely going to still go left, from the origin, we're going to go left 4, down something, right? So we know our x value has to be negative 4, comma, and then we're going to go down to our directrix line, which is negative 5, and then go down 4 more. So from there, we can do negative 5 minus 4 more is negative 9, or halfway between negative 5 and negative 13 is negative 9. Okay, so on here, you'd have negative 9 is where it meets up with your vertex. Okay, so our vertex over here I can fill in now as negative 4, comma, negative 9. And when we go to plug into this equation, that's our h and our k. All right, let's see if you have it memorized. So the equation is 4 times p, parentheses, y minus k, each equals, parentheses, x minus h squared. Okay, so now we have our information here that we need and to plug it in. So I'm going to go up here and label this as our h comma k, and let's plug in. So we got 4 parentheses, I've got -2 as the p-value, times parentheses, y minus, now my k value is -9, so I'm going to plug in -9. Yes, it's going to turn into a positive, but I'm just showing you what it looks like. Parentheses, x minus our h value is -4, so -4 squared. Okay? Then from here we got to simplify. So we've got to multiply outside numbers, so -8 on the outside, parentheses. These two here make a plus, so we're going to get y plus 9 equals, here makes another plus, so we get x plus 4, parentheses squared. Okay, our goal now is to get y alone, so we want to isolate the y here. So what we're going to do is we got to get rid of that number out front, the -8 times that, so we're going to divide both sides by -8, divide this side by -8, and when you do that, the -8's cancel on the left. So, and then we can also drop the parentheses, so we get y plus 9 equals, now again, there was a 1 in front of that parentheses, so I'm going to write this as 1 over 8, but we have to make it negative because there was a -8 on the bottom. And you can just transition that right up to the top. X plus 4 squared. And then our last step is to minus 9 from both sides. Cancel those out, leaving us with y equals -1 over 8, parentheses x plus 4, squared minus 9. Okay? So now what you want to do in this step, you would want to check in the calculator. But if you remember back from Unit 2, what does it mean when there's a plus 4 in the parentheses and a minus 9? Well, plus 4 in the parentheses means you would shift the graph left 4, because inside, remember Hicks boy, would shift it left 4, and then outside -9 would shift it down 9. So let's just check to see that that's what it actually looks like on our graph. So if I start at the origin, is our vertex shifted left 4, down 9? Yes, it is. So it actually checks out. Okay? So one more example. Go ahead, flip over to the next page. For our last example here, example 4, we are given a focus and a directrix where they're not nice whole numbers. So you're given a focus at the point over 10, up 17 over 4. So I graphed this point and went over 10, up 17 over 4. Don't convert it to a decimal. So do not convert to decimals, just leave them as fractions. And then our directrix line was above it because the numerator is larger than the numerator of the focus. So it goes above it, and there's our directrix line. And I need to label that focus point with an F. There we go. Okay, so don't be afraid of fractions. What you should notice is that their denominators are exactly the same number, so 4 and 4. So when we do this, we need to figure out, just like normal, what halfway between here and here is. And then our parabola is again going to be facing down because you can't have it cross over the directrix. Okay, so like I said again, don't be afraid of the fractions. I want you just to look at the numerators. You just want to find halfway between 23 and 17. Okay, because if the denominator is exactly the same, then you are going to you're going to just keep it over a 4. So what you need to do is find halfway between by doing 23 minus 17 equals 6, and then taking 6 and dividing it by 2 to get 3. So that means that when I draw in my vertex here, so I'll do that in another color. So when I draw in the vertex, which we know is going to be somewhere in there, so that's our vertex. The distance between here and here, here and here, our P has to be equal to 3, what we found down here. But since it opens downwards, then that means that our P has to be negative. So it must be negative because it opens downward. Okay, so we've got 3 units in between both of those points there. So our parabola is going to be facing down. And we need to figure out exactly what point that is. Well, we're definitely still going to go over 10. So right 10, up another distance. So our x value of our vertex is 10, comma, now halfway between 23 and 17 is 20. Okay, so you could either add 3 onto 17, 1, 2, 3, bringing you up to 20 over 4 would give us the y value of the vertex. So 20 over 4. Okay. So actually I made a little mistake there. So our p-value is -3, but we just have to make sure we put it over a 4. Because it's really -3/4 because we had the 4 in the denominator there. Okay, so our p-value is actually equal to -3 over 4. Again, because we need those common denominators. Okay, so then coming down here, we've got our p-value as that, and our vertex as 10, 20 over 4. Now we just go ahead and plug and chug into our formula. Okay, so our formula, let's start off by writing 4p, parentheses y minus k, is equal to x minus h squared. Okay, so 4 times our p-value of -3 over 4, parentheses y minus our, so this is hk over here, so our k value is 20 over 4, parentheses equals x minus our h value is 10 squared. Okay, then from here we want to simplify on the outside. So 4 times 3/4 simplifies down to -3 because those 4's cancel out. You're left with -3, parentheses y minus 20 over 4. And then just copy the right side down. Okay, next step here is to continue to try to get y by itself. So I'm going to divide both sides by -3, divide by -3. Those cancel out. Drop the parentheses, y minus 20 over 4 is equal to, again there's that 1 in front, so it's -1/3 because the negative from the 3 on the bottom carries up, x minus 10 squared. And then last step is to add your 20 over 4 to both sides. And you are left with a final answer of y equals -1/3, parentheses x minus 10 squared plus 20 over 4. What is 20 over 4, everybody? It is actually equal to 5. So if you wanted to rewrite 20 over 4 as 5, that would be lovely. Okay? So final answer there. And plug this into your graphing calculator to check. That -10 should shift it right 10 in the parentheses. And the +5 on the outside should shift it up 5. So if I look back up at my graph, did it go right 10, up 5? It absolutely did. Okay, so you could do that and check on your graphing calculator as well to make sure that it matches our graph from our notes. Okay, all right, go ahead and write a quick summary, just some of the key things that you learned, and do all of your practice.